Hey everyone, we are Igem team CSMU Taiwan. We are glad to show you the story about our project. Do you know influenza? Influenza is an infectious disease caused by influenza viruses. It affects 3 million to 5 million people in the world every year and results in about 250,000 to 500,000 deaths every year. It is a worldwide spread disease and worth our better attention. Usually, the viruses are spread through the air from coughs or sneezes, and can also be spread by direct contact and touch mouth or eyes. Taking yearly vaccinations against the subtypes recommended by WHO, frequent hand washing, avoid close contact, and wearing a surgical mask are ways you can do to reduce the risk of viral spread. There are 3 types of influenza viruses that affect humans. The type A is the most virulent one and causes the severest disease. It's classified into subtypes with the differences between their surface glycoproteins, hemagglutinin and neuraminidase. H1N1 and H3N2 are 2 subtypes that caused the latest outbreak among humans these years. Type B almost infects humans only. They mutate slower than type A and consequently is less genetically diverse. As a result, most people already develop some degree of immunity at an early age, and it only causes smaller localized outbreaks compared with type A. Type C is less common than type A and B. The most commonly used diagnostic technique is antibody type screening. It is an antigen-based test involving direct staining of respiratory epithelial cells with fluorescent-labeled antibody. Then, you can examine the result by naked eyes. Professional supervision, specialized environments, and instruments are not required, so showing the result in short time is its greatest advantage. However, it has the disadvantage of low sensitivity and frequent false negative results. Doctors should make diagnosis combining with individual symptoms. In order to improve the existing rapid test kit, we adopted SELECT, which means systematic evolution of ligands by exponential enrichment. Now let's take a closer look at what SELECT is. The main character in this technique are small molecules called aptamers. Usually the DNA we hear about is double-stranded. The main character we use in SELECT is short single-stranded DNA called aptamer. They have several advantages compared with antibodies. For example, they are relatively small in size. They can be made in shorter time and cost lower price. And they are non-immunogenic. All of the advantages are the reasons why aptamers are widely applied in rapid tests and a better choice for treatment. Now let's see how SELECT actually work. The process includes 4 steps. First, preparing the single-strand DNA library. We use the single-strand DNA pool provided by the biotechnical company with a length of 87 per molecule. Second, bind our protein to the beads in the SELECT tube, in our case, an Eppendorf. Then add the single-strand DNA pool into the Eppendorf to make the aptamers bind to the target protein. It takes about an hour. Third, add washing buffer to wash down the aptamers that don't bind to the proteins. The remaining aptamers in the tube are the ones we want that have high affinity with the targets. Then add elution buffer to wash down and collect those aptamers, which then become the single-strand DNA library we use in the next round of SELECT. After rounds and rounds of the steps we mentioned before, we got the aptamers that have the best affinity with influenza protein. Finally, we can synthesize them in a large amount in order for further applications. Our applications include 3 main parts: rapid test, early detection, and treatment. Like our project, you can find more information on our Facebook and Instagram. Like or subscribe our page to give us more encouragement. If you have any questions, just simply leave a comment. We will reply you as soon as possible. Thanks for your watching. We are CSMU Taiwan. The best is yet to come.